Yeah, you can sit around here.
Okay, I sit down.
So we are going to do the calibration. Calibration. You know what is calibration? Anybody can tell me? What is calibration?
Calibrate stuff.
Standard, then after that.
You have to how to say?
Match a certain standard.
Yeah, match your measure, like whatever to a certain standard.
Match.
I mean, not match. Like you have to set it to a certain standard. Like follow the standard.
What's that? What's standard? You measurement.
The standard they give you in the all the methodology or something.
Hey, tomorrow is it this week is a quiz, right?
Next week lah.
Next week.
This week.
This week.
Next
Next
week.
week.
Next
Next week also
after
got.
both.
Next week also got
Yes.
test. Both week got test.
Yeah.
So
Then,
it doesn't matter lah. Both week also got test.
So this is a dial indicator. This is a dial indicator. So a dial indicator is considered as what? What is a dial indicator for? The dial indicator is here. A dial indicator is classified under a process instrument.
Okay. Thank you. I can get this.
Okay, so it start from 0 here. Okay, and one round is 1 mm. So there's one division is 10 micron. 5 division will be
0.5.
okay. Here is 10 micron, 20 micron, 30 micron somewhere around here, 40, 50 micron, 60, okay, 70, 80, 90, 1 mm, and there's a counter here. Okay, 1 is 0 first, then got 1, 2, and so on up to 10 mm. One round, of course, 10 mm. So when you go one round, this one will go 1. Second round will be 2. Any question? There's a counter here, millimeter counter. Okay, then of course there's a pointer here. Okay, so this pointer is the 10 micron pointer. Any question? So for calibration, why we want to calibrate is because after working for some 1 year, okay, every year you need to send for calibration. If you use every day, then probably half a year you need to send for calibration. Okay? And then we need to ensure that it is traceable. Traceable to what? The traceability is very important. Okay? There must be a traceability of this to what? Okay?
Yes.
So traceability, how to ensure this is traceability, you need to send, okay, to an accredited laboratory. Right, the traceability you need to send it. To ensure traceability, you need to send, right, to standard laboratory. Okay, so how to know that this standard laboratory is traceable to here? Make sure that it's accredited. Okay, accredited. So you need to either send it to Mitutoyo, right? Mitutoyo is accredited laboratory. Mitutoyo, it is a company. Okay. Any question? Or you need to ensure that when you send this, or you want to calibrate yourself. Okay, we are calibrating ourselves, right? We need to ensure that to select an instrument. Okay, this is a process instrument, right? We need to select an instrument. Okay, a calibrator, a dial calibrator. Okay, a dial calibrator, and this dial calibrator must be calibrated. Okay, calibrated by accredited laboratory. Okay, so in this case, we send it to Mitotoyo. Okay, you can see it over here. Then over here. Okay, so this is a checker, eye checker. So we need an instrument to calibrate this. What is the instrument?
The dad.
We call eye checker. Okay.
Yes.
The best is you send this, okay, to a standard laboratory. Okay, straight away send it to a standard laboratory, because now we calibrate ourselves. We don't have the traceability. Clear? We don't have the trace. Why? Why you think that we don't have the traceability? What is the reason? If you today we calibrate in NYP, right? This is in NYP, right? Although this is what do you call, calibrated by Mitotoyo, which is an accredited laboratory, but over here there's no link. There's a broken chain here, right? Because we NYP, we are in NYP, right? Okay, our lab here, okay, is not accredited. We are training lab, right? We are not accredited. We are not. Okay, so there's a unbroken change. So if you want this to have a linkage to here, this one there's a link, or this one there's a link. Okay, but here there's a broken link. Clear? So there's no traceability. The traceability actually stop here, but doesn't stop here lah, because all are accredited. Any question? The traceability part. So okay, how to calibrate? So that's the explanation of your next week exam. Okay. So why we should calibrate?
So next week not tomorrow.
Huh?
No, next week got one test.
Okay. No, I mean this one.
No, next week is a topic 1 to 3, right?
Yeah,
so this
yeah.
is topic
Oh,
1.
okay.
But this week we only CMM, only one
CMM,
topic.
yeah.
We never discuss about it.
Yeah.
One topic a bit long.
Okay, tell me now. How should we calibrate this? So the method, the procedure is important. Procedure is important, but our procedure is not accredited lah. What is the procedure? So okay, briefly I explain to you. Okay, the standard procedure is this. Okay, you need the calibration procedure. Okay, so first thing is that you must know the standard way of calibration. Refer to a standard, a written standard procedure. So the procedure say that in the dye indicator there are 4 errors. Okay, what are 4 errors? Anyone? Or 4 parameter. Okay, what is this? First is the span of error. Okay, this is the first one. Second is the local span of error. Okay, and the third is the total span of error. So please read that. All right. And the fourth one is called the hysteresis. Okay? Yeah, hysteresis. So this there's a symbol, there's alphabet. Okay. Oh, yeah. So this is FT. Okay. This one is FE, and this is FGES. Okay, and this is F subscript U. Clear? Okay, so how to in your procedure you need to check all this up. Okay, so we use a software to help us. Alright, we use a software, a standard software, okay, written for this procedure. Yeah. Okay, so first you need to calibrate. The calibration is this way. Okay, you need to calibrate every 0.1 millimeter. Okay, from 0 to 10 millimeter. Okay, any question?
No.
0, then we start from 0, then 0.1, 0.2, and so on, up to 10 mm. So you got 100 reading here. Okay, any question? This step.
No.
Okay, then after that you need to calibrate from 10 mm to 0, the other way around. Okay,
100 reading. Okay.
yeah, so every
Maybe
0.1
100 again.
another 100 reading. So how many reading already?
200.
200. Okay, then you need to this is to analyze this and this. But over here the system will call you to go back here. When you're calibrating 0 to 100 mm, right? You calibrate this, then the system will call you to go back to here, okay, whereby the deviation is the largest. Okay, so this is called local span of error. Then you need to example at this reading here, 0 to 10 mm, maybe at 2.7 to 2.8 here. Okay, it has got the largest deviation. So the software will call you to go back here. Okay, start from 2.7, right? 2.71 to 2.8, another 10 reading here. Okay, so you need to calibrate local span of error. Okay, from 2.7 to 2.8 every
What exercise?
10 micron, because this one division is 10 micron. Okay, any question?
No question.
So that's about this. Then the what else? Hysteresis is the analysis of these two reading. Okay, and okay, hysteresis means what?
History.
Then of course the software will also ask you to calibrate. Number 5,
It is.
the repeatability. But this one I don't require. Okay, F the view. Okay, F the view is at 5 mm. At 5 mm. Halfway. This is 10 mm, right? At half. At 5 mm, you need to measure 5 reading.
Yes.
This one 10 reading. Here got 10 reading.
215.
Yeah, 215 reading. Okay, hysteresis. How to analyze? Just a bit. This is 0, right?
Yeah.
This is 0.1, 0.2, and so on up to 10 mm. So the error will be plot.
One,
Okay, 1.
2.
You got 100 reading. 100 reading. Clear? So this is forward. Then you have backward, right? This one 100 reading, right? You got 100 point, another 100 point. This the other way, right?
So it's down, up.
May not be. Okay. Example. So at every point you got 2 readings. Okay, so the distance between these two, can see?
Yeah.
This one. So this is what called hysteresis. Understand?
Ah. Oh, the distance answer. Distance
At
between
every yeah,
bottom
distance
and the
between-
top.
No, this distance between the forward reading
and the
and the
backward reading.
return reading, backward reading. Okay, or yeah. Anyway, you can refer to the graph.
procedures.
Okay, so we have another 5 minutes. I just demonstrate to you, okay, the software, and that's it. So there's a brief explanation of the calibration procedure. Please refer to your notes, because in the test, okay, I can ask you what is this, what is this, what is this, what is this. Okay? And I can ask you the procedure of calibration. Okay? I can ask you about traceability. What is meant by traceability?
Okay, sure.
Okay. So on the power, on the computer system,
How to get on?
on here.
I don't know. Yeah, that's very bad. What do you want me to do now? All the things that has it sounds like the music. What does she listen to? Huh? I was walking in the music. Shit, yeah. Hey, asking me as asking as if that's all the wrong person.
So again, the same thing. Once the software, once the computer is on, you need to initialize the system. Okay, so remember this is a dial checker or dial calibrator or eye checker. We call eye checker. And every year, although we are in the training, we need to send this one for calibration. Okay, you send it to an accredited laboratory. Okay. So first thing, yeah, iPad. Then you say okay, observe, observe. So inside here, there's a glass scale, very precision glass scale. The spindle will move up and down. Where's the spindle? Anyone? Where's the spindle? What do you think? Where's the spindle? Yeah. Here. Okay. Observe. Okay. Initialization. Any question? Then the window, messy, right? Can see the window is very messy. You just under the window, arrange window automatically. Okay. Then the first step is to do the setting. No. Wait, more the thing. Under inspection, select industrial standard. Select dial gauge icon here. Select the standard, right? Just now I mentioned to you the standard, very important. This one. We need a standard procedure, calibration procedure.
Yeah. Okay.
So the standard calibration procedure that we are following is the DIN. DIN. DIN is what is DIN? It's a German, Dutch. Dutch is German. German industrial standard. It's a German term. Okay. And 187 what? 87? 878. And there's a revision of there's a revision 1993, right? Okay, your standard is always revised every few years. 1983 here. Okay, 1983. Okay, if it's the latest, then we need to change it. Then put next, okay, and then key in the interval.
Oh, correct.
here, the scale interval is stated here, right? 0.1 millimeter. Okay, the range is 0 to 10 mm. Okay, here the counter here 0 to 10 mm. 1 is 1 mm, 2, 3, and so on up to 10 mm. Is this clear? Then finished. You'll generate a spreadsheet for you. You can see, you'll generate all the reading for you to calibrate. Here, the reading is here. So total, how many reading? 215. You just follow. The repeatability 5 mm is here. Local span of error haven't analyzed. Okay, and from 0, every 0.1 to 10 mm, which I mentioned to you, right? Okay, and then from 10 mm here. From 10 mm to 0 again. So you just follow this reading. Okay, then you can clamp your indicator again. Sorry. Here, please clamp. Then you lock it. Okay, you can lower down a little bit here. Slightly tighten will do. Don't have to tighten so tight. Okay. Yeah. Then you now can set. All right. The controller is here. There's 2 buttons here. One is the outer ring. Okay. And then you sit in front. All right. Sit in front here. Why? Why must we sit here? This way. So you don't have a what I call parallax error. Then rotate here until perfectly 0. Okay. Then you can set to 0 here. Set to 0. Okay. Then you can start to do the measurement. Okay. Then you can say OK here. Just follow the instruction. You can key in the manufacturer of the die indicator, the serial number of the die indicator, the issue number of the die indicator, everything. The operator, you can put your name here, inspector. But no need, okay, and then you check before you mount in, you check whether the appearance is okay or not. Okay, if the appearance is not okay, contact tip it's not so good, you just uncheck. Okay, or there's a stain somewhere, you uncheck. If it's okay, then you can calibrate the force. But we don't have a force gauge here, so you just ignore, right? Ignore. Okay, then we can start. Okay, here, start is here. Data correction start. Already set to 0, right? Here 0. Okay, then you'll move very close to 0.1. You can see next reading 0.1. So you adjust perfectly to 0.1. See here, when I add data in, you go to the next reading. Semi-auto. 1 division away from the calibration reading. And then you can plot, check that the plot is okay. Okay, so say supposing, okay, you never adjust properly. Okay, can see it is. If you think that this reading is wrong, just delete, cancel. Okay. Then you can check again. Okay. Any question? Now, if you overshot, you can retry here. You haven't entered, right? You can retry. Okay, any question? So like that you do for 215. You just follow the instruction.
I need to copy down.
Okay, where's your worksheet?
What does the worksheet?
Okay, how's the worksheet?
Yeah.
Yes.
Oh my god.
Okay, your reading will be here. Record down after you finished. Record down the reading here. Okay. The 4 parameter which I mentioned to you, 1, 2, 3, 4. Under the standard, what is the permissible tolerance is stated here. Okay, so follow. Then your reading, actual reading. This is a tolerance, right? According to the standard. Then the reading from your software, you record down here. Okay, what after you 200, you will give you a certificate. On the certificate, record down the reading of the 4 reading. The 4 reading. Then this reading you had to plot for question number 3. Right? There are 3 reading, 1, 2, and 3. Then for question number 4, there's 1 reading. You need to plot, and your plotting and your computer should be very close. But I don't want you to plot every reading. There are how many reading? 200 and 200 over reading. Okay, I want you to plot only 40 reading. 20 reading here, 20 forward 20, return 20.
Okay.
Alright, instead of plotting every 0.1, you plot every 0.5. Is this clear?
Yes.
Yeah. So you can save your data after plotting on a directory. Exactly. Here, program file. iPad, right? Result. Okay. Okay, so I will create a directory here for you. Create new directory. Okay. So your F1 2018 semester number 1. Okay, F8 F1 so you save it here. Am I clear?
Yes.
So I'm going to show you other result. Okay, some of the result is here. The result will be here like this. Okay? Yeah. So you can you plot this reading, you plot this reading, you plot this reading every 0.5. The rest all you discard away.
Yes.
So in other words, your result of the certificate and over here may have a little different. You analyze whether in or out. Okay, that's all about today.